Welcome to Pre-Calculus skill video for skill number 34. I can graph absolute value functions and solve absolute value inequalities graphically and algebraically, including with the use of technology. And the video question is, we have a boot here for our boots unit, and the shoelaces pass through these little holes. What are these called? Alright, for this skill we're going to need to quickly review what sort of transformations we have out there. We have the left-right translation, and that means what we're going to do is we're going to take x and replace it with x minus h. And this will help us move the graph h units to the right. H units to the right. The up-down translation, we take our function, and to that we're going to add a value. So this is going to move us k units upward. So if we had f of x plus 7, we're going to go up 7 units. And if we had f of x minus 3, we're going to go down 3 units. A flip over the x-axis, we take the function, or the y values, and we're going to make them all negative. So that's our flip over the x-axis. Whereas the flip over the y-axis, what we're going to do is we're going to take all of our x values and make all of our x values negative. The next transformation is stretches. So a vertical stretch happens when we take our whole function, f of x, and we're going to multiply it by some number. And if we want to be super technical, if a is greater than 1, it's a stretch. And if a is between 0 and 1, it's a compression. And then we also have the horizontal stretch, and that's when we take our x and multiply it by 1 over b, or you could say divide it by b. So this is going to be a horizontal stretch, and if b is greater than 1, it's a stretch, and if b is between 0 and 1, it is a compression. So let's take a look at some of these transformations on the graph. When I take a look at the absolute value function here, I see that what has happened is it's moved, looks like 1 unit to the right and 3 units down. So 1 unit to the right would give us x minus 1. And then it's moved 3 units down, so from that we're going to subtract 3. And then from the point, the vertex point, I can see it's been vertically stretched. Rather than going out 1, up 1, out 1, up 1, out 1, up 1, we have out 1, up 2, out 1, up 2. So it's been vertically stretched by a factor of 2. So I put in the 2 there, and then just to make an equation, f of x is equal to 2 times x minus 1, absolute value, minus 3. In our second transformation, I can see that the vertex has moved 1 to the left, and it's moved 4 up. So if I want to describe 1 to the left, I'm going to take the absolute value and I'm going to go plus 1. So that tells me the left 1. And then if I'm going up 4, I'm going to subtract, I'm going to add 4 to the absolute value. It's also been flipped over a vertical flip. So that is going to be taking all of our y values and making them negative. So that negative tells us to flip it. And then we also have a stretch. So our vertical stretch looks like we're going out one, up 1/3 of one, out one, up 1/3 of one, out one, up 1/3. Or you can see that the slope is 1/3, either positive 1/3 or negative 1/3. So it has been vertically stretched by 1/3. And there's the function for that. The nice thing about absolute value functions is you can describe vertical stretches very similarly to horizontal stretches. And I'll talk about that more in class, but we could have looked at this as a horizontal stretch if we wanted to. I tend to stick to only vertical stretches with absolute value functions, though. All right, now what we're doing is we're going to go from an equation to a graph. So with this equation, I see that what I've done is I've moved to the right 3. So 1, 2, 3, and then I go up 1. So I know that my vertex is now at, if I can get my pen to work, that point right there. And then the general function is going to just be out 1, up 1, but I notice it has a vertical stretch of 2, so I'm going to go out 1, up 2, out 1, up 2. So we have a absolute value function that looks something like this. It's quite difficult to draw straight lines on the iPad, but on your graph you can draw straight lines. Okay, the second function, I see that we have moved to the left 1 and that we have flipped it. This flip turns it upside down, and then we go down 2. So first we go to the left 1 and then down 2. There's where our vertex is located, and we are flipping it so it opens downward like that. And make sure you're following the slope of out 1, down 1, out 1, down 1, out 1, down 1. Okay. Example 3 is about solving absolute value in equations. And we can do this algebraically or we can do it graphically. So what I'm going to do is I'm going to do it algebraically first, and then we'll check it graphically. So in our first equation, in order to solve it algebraically, first we need to isolate the absolute value. So we're going to add 2 to both sides, and we're going to get 8 is equal to 3 root x plus 1. And then we're going to divide by 3, and we get 8/3 is equal to absolute value of x plus 1. And then we need to split the absolute value equation. So we have either 8/3 is x plus 1 or 8/3 is equal to negative x plus 1. And we do that because that's what the absolute value function is saying, that it takes on those two values. If we solve for x there, we're going to get 8/3 minus 1 is 8, 7, 6, 5/3. So 5/3 is equal to x, or negative 8/3. We move the negative over, we get negative 8/3, and then we subtract 1 from it, so we get 8, 9, 10, 11, negative 11/3 equals x. All right, to solve this equation graphically, or to check it graphically, what we want to do is graph each side. So we're going to graph the left side first. The 6 is just a nice straight line at 6. And then the right side, it looks like we've shifted to the left 1 and down 2. And it has a slope of 3, or a vertical stretch of 3. So out 1, rise 3, out 1, rise 3, L1 rise 3. And we get a function which looks kind of like that. And it doesn't land right on an intersection, but if we were to kind of want to compare it, this is our 5/3 answer. It looks like 1 2/3. That seems about right. And then if we're going to compare our other one, this should be -11/3. And that is what? -3 2/3. That seems to confirm that. So our drawing confirms our algebraic calculations. Moving over to the second example, what we want to do is isolate the absolute value first. So I'm going to add 2 to both sides. I'll get 5 is equal to the negative absolute value of x plus 1. And then I'm going to move the negative across, and I get -5 is equal to the absolute value of x plus 1. From there, I can split my absolute value expression into two different equations. Either I have -5 is equal to x plus 1, or I have -5 is equal to negative x plus 1. If I continue to solve this down, I'm going to get on my first one, subtract 1 from both sides, and I'll get -6 is equal to x. And then if I do it for the second one, I'm going to have 5 is equal to x plus 1, or 4 is equal to x, not 6. So let's check this out graphically, because I'm noticing something that seems a little bit odd. First off, we're going to graph our horizontal line, which is at 3. So we want to graph a horizontal line at 3. And then we're going to graph the function that we have here, which appears to have moved to the left 1 and down 2. So we go to the left 1 and down 2. And then it opens, it's reflected, so it's opening downward. That's what that negative in the front means. So it opens like this. So this graph appears to never cross this line. So why were we able to get two solutions? What's going on here? We got two solutions because there was a step which we did not examine closely. And this is actually why I like checking graphically. Taking a look at this step right here, we're saying the absolute value of something equals a negative answer. And this never happens, because the absolute value actually takes and gives us the positive result. So this work here we could not even do, because this will never happen. So at that point we should have written no solution. If you're curious what the numbers -6 and 4 actually do mean with relation to the graph, if we were to continue drawing these lines upward, we would find that that is where they would intersect if they didn't stop. But right here, that's when we should recognize the no solution. So it's important for us to either see that when we're solving it algebraically or when we check it graphically. It's a tricky one. All right, moving along, we're going to go to the next page.
Граница Украины с Россией перекрыта. Об этом в Киеве заявил Арсен Аваков.
Find the x-intercepts and y-intercepts of each function. And when we're asked this, we should remember that an x-intercept will occur when the graph crosses the x-axis, or when y is 0. So if we let y be 0, we have this problem here, and we need to solve this problem. Add 2 to both sides, and then divide by 3, and we get 2/3 is the absolute value of x minus 7, which means either 2/3 is equal to x minus 7, or 2/3 is equal to negative x minus 7. So if we solve each of these problems, we're going to get 2 answers. Let's work them out. 2/3 plus 7, or you could say 21/3, so we get either 23/3 is equal to x, or we're going to have negative 2/3 plus 7 is going to be 19/3 is equal to x. If we want to solve for the y-intercept occurs where x is 0. So there is only one possible y-intercept, and it's going to occur when x is 0. So we write f of x is equal to 3 times the absolute value of 0 minus 7 minus 2, and that is going to be 3 times 7 minus 2, or at 19. So with this, we could actually roughly draw out a graph, and our graph would have a y-intercept up here at 19, and then it's going to have 2 x-intercepts over at 23/3 and 19/3. And then our graph is going to basically pass through those 3 points. Something to that effect. So it is a useful way to draw a rough sketch. All right, finally we want to solve inequalities. And this is a little different than solving an equation. We want to first isolate the absolute value. So what we do is we add 2 to both sides, and we get 8 is less than 2 times x plus 3 absolute value. Divide by 2, and we get 4 is less than absolute value of x plus 3. And then we split it into 2 separate equations. We either have 4 is less than x plus 3, or we have 4 is less than negative x plus 3. And then we want to solve each one of those. So the left one we solve, subtract 3, and we get 1 is less than x. Or if we solve the right one, first we'll multiply the negative across and not forget to flip the inequality. And then we subtract 3, and we get negative 7 is greater than x. So we have a number that's less than 1, is greater than 1, or less than negative 7. So it looks like we have a disjunction. So we have this condition. Let's take a look at that graphically. So we're going to draw our left side. Our left side is 6, so we've got a horizontal line at 6, and then we're going to draw our right side. What we have is a graph that shifted to the left 3 and down 2. So our start point is there, and it's been vertically stretched by 2, which means there's a out 1, up 2 sort of slope that's going on here. And again, I'm sorry that I can't draw perfectly straight lines on my iPad. And then we want to know, when is the absolute value above the line? So the spots that are of interest to us are this portion, because the absolute value is above the line there, and this portion, because the absolute value is above the line. So that is why we have 2 separate answers. or an answer that consists of two parts. So helping us with drawing a transformed graph actually really helps us understand how this answer relates to the graph. Let's do it again with the next problem. The first thing we want to do is we want to subtract 1 from both sides, and we will get 4 is greater than or equal to the negative absolute value of x minus 4. And then we're going to divide the negative across. So we want to know, when is 4 less than or equal to the absolute value of x minus 4? At this point we could be like, well geez, the absolute value is always positive, so if this is negative, our answer should be all numbers. But let's continue this out and see what happens. The first thing we're going to do is split the absolute value into two separate problems. So we have either negative 4 is less than or equal to x minus 4, or we have negative 4 is less than or equal to negative x minus 4. And we solve the left one first by adding 4 to both sides, and we get 0 is less than or equal to x. And then we're going to work on the right side. So let's multiply the negative across, and we are going to get, when is 4 greater than or equal to x minus 4. And we then add 4 to both sides, and we arrive at x is less than or equal to 8. So if we think about this, our two answers we're going to think as a number line. We're interested in x being greater than 0, greater than or equal to 0. So all these numbers, and then our second one we have x is less than or equal to 8. So all these numbers. So we should probably have all numbers. But let's see what this looks like graphically. First we're going to graph the line, the left side, and we're going to get a line at 5. And then we want to graph our absolute value function, which has been shifted to the right 4 and up 1. So we go to the right 4 and up 1. And then we also have a reflection. So this tells us it's going to open downward. So we draw the graph opening downward. And then we ask ourselves, when is the absolute value underneath the line? Or when is the line above the absolute value? Well, the line is above the absolute value everywhere. Hence, our number line or our solution works. So we get a solution of all real numbers. All right, after this video you should have a better idea of how to graph absolute value functions, especially with their transformations, and use this as a means to solving absolute value inequalities, either both graphically or algebraically, and with the use of technology, which we'll go over more in class. The answer to the trivia question is this boot here has a shoelace passing through what is called a grommet. That is Grommet, not to be confused with the character Gromit of Wallace and Gromit. All right, and as a reminder, please give me a thumbs up if you think this video was useful in teaching you the lesson, or a thumbs down if the video was confusing to you. Thanks.